Hello, everyone. Moving on into Unit 3, Section 3-2. Title of the lesson today is Solving Inequalities Using Addition and Subtraction. Let's get started. All right, so Arikan, Staben, there's two of them today. I can write and solve inequalities using addition and subtraction, and I can solve real-life problems. So this is going to be really similar to solving equations, except we're now replacing equations with inequality. So we have our two key ideas, which is addition property of inequality and the subtraction property of inequality. The addition property of inequality basically says if you have an inequality, if you add the same number to each side of it, the inequality remains true, okay, similar to an equation. The subtraction property of inequality states, similar to equation, that if you subtract the same number from each side of an inequality, the inequality remains true. Let's take a look at example 1. Solve x minus 6 greater than or equal to negative 10. Graph the solution. Okay, so what you're trying to do, you see our x here on one side of the inequality symbol. And what we need to do is we need to do the inverse of the subtracting of 6. Okay, so if you remember back with the equations, very similar to that, we're going to take our equation and we're going to, let me get my right pen here. So we want to think of inverse of subtracting 6. The inverse of subtracting 6 is adding 6. So if I add 6 to the left side, I have to add 6 to the right side. And by doing so, we have x by itself on the left. Greater than, equal to, negative 10 plus 6 is negative 4. Okay, so our answer is x greater than or equal to negative 4. So we want to graph it to illustrate all of the possible solutions to this. So let's find out where negative 4 is, and we're going to put a solid dot. Okay, a solid dot because we're including the negative 4 with the greater than or equal to symbol. So we're looking for everything greater than or equal to this negative 4. So we're going to shade everything to the right, greater than or equal to. And if you're going to check your solution, you could put 0 in there or negative 2 in there. 0 minus 6 is negative 6, which would be greater than or equal to negative 10. So you want to check your solution to make sure that you are graphing correctly. Second page. On your own, we have 3 of them. Let's start with number 1 first. So basically what we have here on these on your own is that we have 3 inequalities. We're asked to solve them using addition and subtraction. And we'll start with number 1 first. B minus 2 greater than negative 9. So again, we're trying to look for the inverse of subtracting 2. The inverse of subtracting 2 is adding 2. So if we add 2 to the left side, we're going to add 2 to the right side, and you end up with B is greater than negative 7. B is greater than negative 7. So we're not including the negative 7. We're going to have a circle at negative 7, and then we're going to turn around and we're going to graph everything greater than that on our number line. Again, so if you were to check a number here, I like 0. 0 minus 2 is negative 2, and that would be greater than negative 9, and that would check out. On your own, number 2, m minus 3.8 less than equal to 5. M minus 3.8 less than or equal to 5. Again, we're looking to do the inverse of subtracting 3.8. In that, it would be adding 3.8 to both sides. If you add 3.8 to both sides, now we have on the left side, that cancels out. We have m is greater than or equal to 5 plus 3.8. 5 plus 3.8, which would be 8.8. So let's find approximately where 8.8 is, which will be right about in here. And we're going to put a solid dot at 8.8. Okay. And we're going to graph everything less than or equal to 8.8. So everything less than or equal to 8.8 would be graphed for number 2. Number 3, 1/4 greater than y minus 1/4. 1/4 greater than y minus 1/4. So again, we're looking to isolate this y, get it y by itself. So we're looking to look at the inverse of subtracting 1/4, which is adding 1/4 to both sides. I know it's a fraction, but we have y is less than 1/4 plus 1/4, which is 1/2. So your answer is y is less than 1/2. So again, what you're going to do is you're going to find out where 1/2 is, and you're going to put a circle there, okay? A circle at 1/2. We're going to graph everything y less than 1/2. So we're going to graph everything less than 1/2. So again, what we're trying to do is we're trying to solve the inequality by using our inverse operations, adding and subtracting. Let's take a look at example 2. -8 greater than 1.4 plus x. -8 greater than 1.4 plus x. Okay, so this is where the x is. So what we're going to do is, again, we're trying to isolate that x, and it's adding. So in order to do that, we're going to subtract the 1.4 from the right side. And if we subtract 1.4 from the right side, we subtract 1.4 from the left side of the inequality. And you end up with x is less than -8 minus 1.4, which would be -9.4. So again, just like I did the last problem here, I flipped it around and started with the x first. X is going to be less than -9.4. And it's just a good practice because it seems like it's easier to identify your graphs, identify your solution set when you have the x as the main part of your inequality. So you're at -9.4, which is going to be right about down in this area, and it's going to be a circle. Okay, we're not including the -9.4, and we're going to graph everything x less than that. Less than that. So if you put a number in like -10, -10 plus 1.4 would be less than -8. Okay, so that would check out. 0 would not. 0 plus 1.4 would be greater than -8. So you always want to check to see where we're at with regards to your solution set. Okay, so we have 3 more on your own here on this section after example 2. Number 4 is k plus 5 is less than or equal to -3. Number 5 is 5/6 less than or equal to z plus 2/3. And number 6 is p plus 0.7 or 7/10 greater than -2.3. Let's give those a try right now. Okay, so if you look at this plus 5, we're trying to isolate that k or get k by itself, and we're using our inverse operation. So inverse of adding 5 would be subtracting 5 from the left side. And if we subtract 5 from the left side, we're going to have to subtract 5 from the right side. So k then ends up becoming less than or equal to -8. Okay, so let's find where -8 is, and we're going to put a solid dot at -8. The solid dot at -8 would indicate we're including the -8. So we're going to then also graph all of the solutions that would be less than -8, which would put us on shading everything to the left. In this case, k is less than or equal to -8. Not a lot of difference between the first three on your owns and the next three on your owns. It's mainly a little bit tougher in finding the variable, and it's pretty much the same. So let's take a look at number 5. 5/6 is less than or equal to z plus 2/3. Okay, so again, we have a fraction here. See where our z is, and we have adding 2/3. So for thinking about the inverse operation of adding 2/3 would be subtracting 2/3. So if I subtract 2/3 from the right side of my inequality, I got to subtract 2/3 from the left side of my inequality. So common denominator in this case between 5/6 and 2/3 will be 6. So 3 times 2 is 6. So 2 times 2 is -4. Well, because the negative is -4/6. Okay, so we're going to, I should pull that back. This is 4/6. Okay, so we're going to subtract 4/6 from 5/6. Okay, so 2/3, common denominator 6 would put us at 4/6. 3 times 2 is 6, and 2 times 2 is 4. And now we're going to subtract 5 minus the 4 is 1. 6. And this cancels here. So you end up with less than or equal to z. Z. So your solution set will be z greater than or equal to 1/6. Greater than or equal to 1/6. So let's find 1/6 first, which is right about in here. Okay, fairly close. We're going to put a solid dot at 1/6. And if you want to label that 1/6. So solid dot at 1/6. And we're going to graph everything greater than that. Okay. Now, when we flip those this around, just like the last one, or I think number 3, and from the previous, we just flipped it around. And it's just much easier to identify our set. Z is greater than or equal to positive 1/6. And that would be your solution. So if you think about it, if you think about a positive 1/3 plus 2/3 would be 1, and that would be greater than 5/6. Okay. Another example would be 2. 2 plus 2/3 and 2 and 2/3 be greater than 5/6 for that number 5. Okay, on your own number 6, p plus, this got shifted down a little bit. Let me move it up. Okay. P plus 7/10 greater than -2.3. Okay, so as you approach this last on your own, think to yourself, how am I going to undo this adding of 0.7 or adding of 7/10? How am I going to undo it? We're going to subtract it from the left of the inequality and subtract it from the right of the inequality. Okay, so adding and subtracting negative numbers, positive and negative numbers, a little bit of a challenge sometimes, but take a look. This cancels out. We end up with P is greater than, and it's -2.3 minus 7/10, and that would be a -3. -3. So on the last one here, we're going to graph everything P greater than -3. So let's go to -3 here. And we're going to put a circle around it because we're not including the -3, but we're going to turn around and we're going to add, we're going to go everything greater than that for our solution. So if you put 0 in there, you can check it out. 0 plus 0.7 is 7/10 greater than negative 2.3. That checks. If you put negative 10 in, negative 10 plus 7/10 would be a negative 9.3, and that would not be greater than negative 2.3. So you want to check where you're shaded, the region where you're shaded, something in there, just to make sure that you have correctly shaded the inequality. Okay, our last and final page includes example 3, and then we have one last on your own for this section. Remember, the section's on solving inequalities using addition and subtraction. And it should come fairly quick to most all of you because of your skill that I've seen with equations. Okay, so inequalities with adding and subtracting is very similar. Let's do the last example. On a train, carry-on bags can weigh no more than 50 pounds. Your bag weighs 24.8 pounds. Write and solve an inequality that represents the amount of weight you can add to your bag. So on a train, carry-on bags can weigh no more than 50 pounds. Your bag weighs 24.8. So you've got one bag already. Okay. Your bag weighs 24.8. So it already weighs 24.8. So you want to know, write and solve an inequality represents the amount of weight you can add to your bag. So they already tell you that you're going to be adding. Okay. So this is what you're going to add, this X plus 24.8. Now we got to place in there the inequality symbol representing no more than 50. Okay. So some of you remember this from the first section, which would be our no more than. So it has to be, it could be 50. Okay, so we have to include the equal sign, and it's got to be less than or equal to 50. Okay, so if that didn't come to you as quickly, the notes from 3.1 would indicate the no more than symbol. Okay, so if you look back, 3.1, your notes would indicate no more than is no more than would be less than or equal to. Okay, so this less than or equal to sign, if you look back at the 3.1, the top part of the notes, third column over, is no more than. It's the third bullet point down on those notes. So that's that chart. That's your friend. Make sure you keep that chart close to you. So there's your inequality. X, which you're going to add. This is what you're going to add to your bag. Okay. And you already have 24.8 pounds in there, is no more than 50. Okay. So let's take a look at how to add. So we're going to subtract, in this case, this 24.8 pounds from the left, and we're going to subtract 24.8 from the right. So what you're going to add is X. So X is what you're going to add. And if you have flow, and this is commonplace when you go to weigh your bags before you get on the plane. In this case, it's a train, okay? Less than or equal to 50 pounds minus the 24.8, which would be 25.2 pounds. So it says, write and solve an inequality that represents the amount of weight you can add to your bag. Now, some of you are just going to come up with the answer and say it in your own words, but you're going to want to be able to do this inequality. So what I've got an arrow there, you're going to want to be able to write the inequality in x plus 24.8 less than or equal to 50. In that case, your answer is your bag could be less than or equal to 25.2 pounds. And the last one today on your own, number 7. Let's say your carrying on bag weighs 32.5 pounds. Write and solve an inequality that represents the possible weight you can add to your bag. So it's kind of the similar question. The only thing that changes here is that your carry-on bag is 32.5 instead of 24.8. So again, X was what we're going to add, plus 32.5 pounds is your carry-on bag. And that has to be less than or equal to 50 pounds. Okay, so again, it's the same weight restriction of 50, but now instead of your weight of your carry-on bag at 24.8, it was increased to 32.5. Okay, so to solve this inequality, the inverse operation of adding is going to be subtracting the 32.5 from the left, and we're going to subtract 32.5 from the right. And in this case, your carry-on bag has to be less than or equal to 17.5 pounds. 17.5 pounds. So what's important here on these last two would be your ability to identify your keywords, okay, and create that inequality, okay? So if you have to draw a picture, like I drew a picture of a bag, it's a strategy. Look for your keywords. We found that no more than added to your bag indicated addition. So those are some little strategies that you can use to help solve for that. Okay, so that wraps up the lesson today. Keep an eye on the work that needs to be done. Section 3-2, it's the second topic of Unit 3 for this class, solving inequalities using addition and subtraction. And you find that it's very similar to adding, subtract, or solving equations, except now we're looking at inequalities, okay? So with our inequalities in mind, we use our two properties. Whatever you add to one side, you have to add to the other. Whatever you subtract to one side, you subtract the other. And we did a bunch of examples, 2 examples and 6 on your own, and then 1 last word problem today. So make sure you do your graphs correctly. We'll help you understand those areas that are solutions. And that concludes the lesson today. If you have any questions, make sure you get a hold of me. Thank you very much for listening, and I hope you have a great day. Take care now.